Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P2184, indicates a low voltage issue with the Engine Coolant Temperature, ECT, Sensor 2 circuit in Honda Civic models from 2006 to 2011. The ECT sensor is critical for informing the engine control module, ECM, about the temperature of the engine coolant. This information is used to adjust fuel injection, air-fuel ratio, and ignition timing for optimal engine performance. Specifically, ECT Sensor 2 is located in the engine compartment, typically near the thermostat housing, making it accessible for inspections and repairs. The low voltage reading suggests a potential fault in the sensor circuit, which can lead to performance issues and trigger the check engine light. Addressing this code promptly is essential to ensuring your vehicle runs smoothly and efficiently. The Engine Coolant Temperature, ECT Sensor 2, is vital for monitoring the engine's coolant temperature. Its main role is to provide the engine control module, ECM, with accurate temperature readings, which helps in optimizing engine performance by adjusting various parameters such as fuel injection and ignition timing. This sensor is typically located near the thermostat housing in the engine compartment, ensuring it's positioned accurately for effective temperature measurement. A low voltage signal from this sensor, typically below 0.08 volts, indicates a potential fault, disrupting the entire engine management system. Such a scenario can lead to suboptimal engine operation and decreased fuel efficiency. Understanding the exact location and function of the ECT Sensor 2 is crucial for effective troubleshooting of DTC P2184. The diagnostic text provides several possible causes for the appearance of DTC P2184. First, poor connections at the ECT Sensor 2 can lead to inadequate signal transmission to the engine control module, ECM. These poor connections might be due to corrosion, dirt, or wear over time. Secondly, loose terminals at the engine control module or powertrain control module, PCM, can cause similar issues, affecting how effectively the sensors relay information. Lastly, a faulty ECT sensor itself could be the root cause. Such faults may manifest as internal sensor failures or physical damage. Thoroughly checking all these components is essential for diagnosing the issue behind DTC P2184 effectively. Typical symptoms associated with DTC P2184 include an illuminated check engine light, which acts as a warning signal to the driver that there is a fault in the vehicle's engine management system. Additionally, you may notice engine performance issues, such as rough idling, hesitation during acceleration, or stalling, signs that the engine is not operating optimally due to incorrect temperature readings. Moreover, poor fuel efficiency may occur as the fuel-air mixture is not appropriately adjusted in response to the inaccurate coolant temperature. Recognizing these symptoms not only helps in understanding the fault, but also in taking timely action to prevent further damage to the vehicle. The first step in troubleshooting DTC P2184 involves turning the ignition switch to the on position, or II, which allows the vehicle's onboard systems to power up without starting the engine. Next, it is crucial to check the ECT Sensor 2 in the data list using the Honda Diagnostic System, HDS. This diagnostic tool will display real-time data from various sensors, including ECT Sensor 2. You should specifically be looking for values around 356 degrees Fahrenheit or 180 degrees Celsius or below 0.08 volts. If the reading meets either of these conditions, it indicates that the sensor might be exhibiting a fault, leading to the DTC being triggered. If the reading falls within the acceptable range, it suggests an intermittent failure, and the system may be fine at that moment, warranting further inspection of connections. After completing the first step, Turn the ignition switch to the lock position, or 0, to ensure that the vehicle's electrical systems are completely powered down before proceeding. With the ignition off, carefully disconnect the ECT sensor 2-pin connector. This connector is crucial for the sensor's communication with the engine control module (ECM). Ensuring a secure disconnection is vital to avoid any accidental short circuits during the subsequent checks. After disconnecting it, you can move on to the next step, which involves checking the ECT sensor 2 readings once more, while leaving the connector disconnected to isolate any electrical issues that might be affecting the sensor's performance. After disconnecting the ECT sensor, once again turn the ignition switch to the on position, or 2. This action powers the vehicle's systems without starting the engine, enabling the diagnostic tool to receive data from the ECT system. Use the Honda Diagnostic System HDS to check the ECT sensor 2 readings again. This time, you're looking to see if the readings remain around 356 degrees Fahrenheit, 180 degrees Celsius, or lower than 0.08 volts. If they do, this could further confirm that the circuit is defective or that the ECT sensor is malfunctioning, as the readings should ideally align with the normal operating range. If, however, the readings are normal, you may need to check for intermittent failures, which could hint at other underlying electrical issues. Upon completing the previous steps, turn the ignition switch back to 0 or lock to fully power down the vehicle's electrical systems. This is crucial for safety and for accurate measurements. Following this, use the Honda Diagnostic System HDS to jump the SCS line, which stands for the Sensing Control System. This jump aligns the diagnostic system to determine if there's a grounding issue within the circuit. The purpose here is to check the integrity of the circuitry while bypassing potential faults that the vehicle's systems might display without this procedure. After successfully jumping the SCS line, you can proceed to further inspection of the engine control components. Once you've jumped the SCS line, turn the ignition switch to the lock position again before disconnecting the ECM, Engine Control Module, or PCM, Powertrain Control Module, Connector A, which consists of 44 pins. This action isolates the ECM from the rest of the vehicle's systems, allowing for a clear perspective on whether the issue lies with the sensor circuits or the ECM itself. Next, perform a continuity check between the ECT sensor 2 2-pin connector terminal number 2 and the body ground. Continuity checks are essential to verify that the wiring is intact and functioning properly, without shorts or opens that could cause incorrect readings, thereby leading to the DTC being triggered. After following the troubleshooting steps and addressing any issues found, it's time to reassemble the components carefully. Make sure that all connectors are securely fastened and that the wiring is routed correctly to avoid physical damage. Once everything is back in place, it's crucial to test the functionality of the ECT sensor 2 again. Use the Honda Diagnostic System HDS to check if the readings now fall within the normal parameters. If successful, this should clear DTC P2184, ensuring the engine control module can accurately read the engine's temperature, which is vital for optimal engine operation. Testing post-repair ensures that any previous issues are resolved and that the vehicle's performance is restored. Preventive maintenance plays a crucial role in avoiding the recurrence of DTC P2184 in the future. Regular inspections of the engine coolant temperature, ECT sensors, and other components associated with the engine management system are vital. Ensuring that the connectors are clean and dry will help maintain optimal electrical connections, preventing issues stemming from corrosive elements and dirt that might impede signal transmission. Additionally, checking for proper mounting and securing of sensors can further protect them from physical damage. Lastly, routinely reviewing diagnostic data can provide early warnings of potential problems, allowing for timely interventions. In conclusion, understanding the role of the Engine Coolant Temperature (ECT) sensor 2 is paramount for diagnosing and addressing issues associated with DTC P2184 in Honda Civic models from 2006 to 2011. By following the specific troubleshooting steps outlined, technicians can effectively isolate and rectify any faults. The importance of performing preventive maintenance cannot be overstated. Regularly inspecting electrical connections and ensuring sensor integrity can significantly reduce the likelihood of encountering similar issues in the future. By staying proactive with vehicle maintenance, drivers can guarantee smooth operation and optimized performance, ultimately enhancing the longevity of their Honda Civic. Please like and subscribe to the channel. See you next time!